Hi everybody, this is Mr. Beckstrom, and today I want to take a look at section 5.4. It says this is the other trigonometric functions and their graphs. And I really want to take a dive into the unit circle and how we define the 6 trigonometric functions as far as when we see something like the sine of pi over 4 or the cosecant of 3 pi over 4 or any of these things, because we're going to be seeing these a whole lot in this class and in the next classes if you're going to take calculus or anything beyond this. So what I did was I found a unit circle. This has all of the main angles that we're going to be using. I'm going to talk a little bit about the unit circle. And I also copied and pasted the definition for the tangent, cotangent, secant, and the cosecant functions from page 446 from our book. And I put it right here because we're going to be using that when we do some of the problems from page 455 in our book. And I'm going to do some of those problems from numbers 7 through 32 in the book. And we'll be using this definition along with this unit circle to do some of those problems there. All right, so let's first talk about this unit circle, and I also just put up a video in resources from Khan Academy that says the introduction to unit circles. It's a really good video just kind of explaining how the unit circle works, so please watch that. I think it's a little bit less than 10 minutes, so not too long. But it really kind of builds it for you and shows how it forms the right triangles and gives us all of our angles with the sine and cosine, all that good stuff. All right, so here's the unit circle here. It's just a circle of radius 1, which is centered around the origin, 0, 0. So we have this circle with radius, so it goes through the points 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And it also goes through all of these points on the circle as well. So the square root of 3 over 2, 1/2, root 2 over 2, root 2 over 2, and you can see all these points as well that it goes through on the circle. So these are all points that it's going through on the circle. Now, I'll start with these degrees first. These are all degrees of the circle. So starting with 0 degrees, a complete circle is 360 degrees. I don't see the 360, but a complete circle is 360. So if you start here, this is 30 degrees, 45 degrees, 60 degrees, 90 degrees, and you can just keep counting 180 all the way until you get to 300. Here's 330 and here's 360 degrees, and you could keep going if you wanted to. That would add just another 30. So if you kept going in a circle, that would be 390. That would be 360 plus another 90 would be 450. You could go 2 complete circles would be 720, and you could just keep going counterclockwise as much as you wanted to. Just keep adding as many circles as you wanted. And you could go the other direction as well. So you could go clockwise, and that would be going negative degrees. So if you started here at 0 and you started going in this direction, going to here would be negative 90. Going to here would be negative 180. This would be negative 270. That would be negative 360. So we actually defined going in the negative direction, going counterclockwise. That would be the same direction as a clock would be going. So that would be going counterclockwise. All right, and just when you thought that things couldn't get any more complicated, they also defined things in terms of radians. Radians is commonly associated with pi. So that little pi symbol there, which hopefully we've heard of that before. That's that irrational number, 3.14159265. That number that goes on forever and ever. So it's that number that is directly associated with the diameter of a circle, right? So if you just take the distance and force that into a circle, it's that number there. All right, so if you go in this direction here, so a half of a circle would be pi radians. And so this is 1/6 of a pi, so that's the same. 1/6 of a pi is pi over 6. This would be 2/6 of a pi, or that 2/6 goes down to pi over 3. This would be 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, which reduces down to 3 over 2, 10/6, which reduces down to 5 over 3, 11/6, and 12/6, which is going to reduce down to 2 pi. So a complete circle would be 2 pi, and we can just keep going up. So that's 12/6, that would be 13/6, 14/6, 15/6, and we could just keep going up just like we did with the degrees. And we can also go in the other direction as well. So -1/6, -2/6, -3/6, -4/6, -5/6. We can keep going in the counterclockwise opposite position as well if we wanted to go negative. Notice that when I did that, I skipped the 45-degree angles. I was not counting those because they're a little bit different than the 30-degree angles. So these are the 45-degree angles kind of divide the pi into quarters instead of sixths. So if I'm drawing the unit circle from scratch, I'll usually do the 30-degree angles first, right? So get all my 30-degree angles first, and then I'll go back and I'll do the 45-degree angles because that divides it into fourths. So then I'll do 0, 1 pi over 4, 2 pi over 4, which is already there, right? Because that's the same as 3 pi over 6, 3 pi over 4, 4 pi over 4, which is already there because that's the same as 6 pi over 6, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. So this is how we kind of build our unit circle. So the pi over 6 and 30 degrees are going to be the same angle, just like 225 degrees and 5 pi over 4 are going to be the same angle. That's pretty much kind of what we need to know as far as building our unit circle. Usually when I have a seated class, one of the first things I'll do is I'll have everyone build one from scratch. But with the online class, I'm just going to say, please watch the videos and become really familiar with it. We're going to be using this a lot. And if you have any questions, let me know. And one last thing. We're going to be talking a lot about coterminal angles. So coterminal angles are two angles that point in the same direction. So for example, if you have a 30-degree angle, so it points in this direction here, and you add, let's say you add 360 to that, so you also have the 390 degrees, which also points in that direction. Those two angles would be coterminal. So they're basically, in essence, the same angle because they point in the same direction, so we call those coterminal angles. And if we were to say put that in standard position just means between 0 and 360. So we would put it in one of these angles here. So if it was 390 degrees and we said to put it in standard position, we could just subtract 360 from it and put it in the same direction, but now it's between the 0 and 360. Or if it was in radians, we put it between 0 and 2 pi. All right, so now let's do a few of these from page 455. These are from 7 to 32. So I'll do about, I don't know, 7 or 8 of these just to kind of get us going here. So let's start with number 7. It says the tangent of pi over 3. So the tangent of pi over 3. Pi over, man, this is going to go slow if I can't write. Pi over 3. All right, so here's what I do. I go over here and I say that is equal to y over x for that angle, right? So I go to pi over 3. So there's my y value, there's my x value. So this is equal to square root of 3 over 2, because that's my y value, over my x value, which is 1/2. So if we remember, hopefully we learned this before, especially in pre-calculus algebra. So if we have a fraction over a fraction, we can do the top times the reciprocal of the bottom. So just flip the bottom around, and that's going to be equal to, that'll cancel, and I just left with the square root of 3. Now, can we do this in our calculator? Yes, we're going to have one issue, and let's see what that little issue is going to be. Let me make sure that I'm in radians. So, mode, I am in radians. So now if I do the tangent of pi over 3, tangent of second pi over 3, and you're about to see what this little issue is. I get that number here. Now, I could put that, but I would get points off because this is not an exact value. I probably would not know that that was the square root of 3 if I was a student. Now, if I had an inkling that that might be the square root of 3, what I might do is because our calculators don't convert this, at least not these ones. There are some newer ones that do, but not ones that you can use for this class. But I might have an inkling that this might be the square root of 3. So if I was a little bit clever, I might say, is that the square root of 3? I might go like this. I might say second square root of 3. And say, oh, look, these are the same things. Yep, that is the square root of 3. So I'm going to go ahead and put the square root of 3. But there's no way to convert that to the square root of 3. So if you do like if you try to do like a math and convert that to like a fraction, then there's nothing that's going to convert that for you. So when we get an answer that's an irrational number, like a root, the calculator is not going to do the root. It's going to do a decimal approximation. And a lot of times we want the exact answer like in a root. So the calculator is not good for that. All right, so that is our answer. Would just be the square root of 3. So let's look at another one here. I'm going to jump around. Let's look at number 13. This is the cotangent of negative pi over 3. The cotangent of negative pi over 3. All right, getting a little bit harder here. So this is how I would do this one, and I'll go back and do a couple of simple ones because I know I didn't do those before. But all right, so pi over 3 is right here. So I went up like 3 points to get here. So negative pi over 3 would like be 3 points in this direction, right? So positive pi over 3 is here. So negative pi over 3 would be there. Tangent is y over x. So cotangent is x over y. So this would be 1/2 over negative root 3 over 2. So this would equal to 1/2 times negative 2 over root 3. And that would equal to negative 1 over root 3. And often what we like to do in math is we don't like to leave a root in the denominator, so we multiply the top and the bottom by the root to get the to rationalize the denominator here. So we multiply the top and the bottom by a root 3. So our final answer would be, I'll just write it right there, would be negative root 3 over 3. And that's how we would leave it right there. And remember, And I'm going to write this here, that the cosine of alpha is equal to x, if you didn't know already, and the sine of alpha is equal to y. So if I said, what is the cosine of pi over 2? You would say it's 0. If I said, what's the sine of pi over 2? You would say that's 1. If I said, what's the cosine of 5 pi over 4? You would come over to 5 pi over 4 and you'd say, oh, that's the x value there. That's negative root 2 over 2. If I said, what's the sine of 5 pi over 4? You would say, oh, that's negative root 2 over 2. All right, let's do a couple of more of these. Let's do number 27. That's the secant of negative 120 degrees. So the secant, of negative 120 degrees. Okay, so let's see. So with this one here, I want to go ahead and put this in standard position instead of trying to like figure out where this is going to be. So I can easily do that using coterminal angles. So I'm just going to go ahead and say negative 120, oops, negative 120. And if I just add 360 to that, that'll be a coterminal angle because I'm just adding a full circle to it. So it's going to point in the same direction. So that's fine. So that's the same as 240. So this is equal to the secant of 240 degrees. So I can do that. Because remember, you can add or subtract multiples of 360. So the secant of 240 is right here. And the secant is 1 over x. So that is equal to 1 over x over negative 1/2. Negative 1/2, which is just negative 2, right? Because it's 1 times the inverse. So that would just be negative 2. And let me double check that. And that is correct. All right. Let me go ahead and erase some of this here. That one is negative 2. So it's out of the way. Let me get 2 more of these in here. How about, let's do one of those. The secant of negative 90 degrees. The secant of negative 90 degrees. The secant, I'll do this one a little bit different. The secant of negative 90 degrees. All right, so I can either add 360 degrees to that to find the coterminal angle in standard position, or I could just say, hey, this is positive 90, so that's negative 90. So this is equal to secant 1 over x, so 1 over the x value, which is 0, and can't divide by 0, so this thing is undefined. Undefined there. So that's what I would put, undefined, UD, undefined. All right. And let's do one more. Let's do the cosecant. Let's do the cotangent of negative 90 degrees. The cotangent, this will be the last one. The cotangent of negative 90 degrees. 90 degrees. All right, so negative 90, we already know which direction that is. I could also add 300. Let's do that this time. So if I were to use a coterminal angle, I could just do negative 90 plus 360. And that would put it in standard position. So that's 270. I already know that points in that down direction. So that would be cotangent is x over y. So that's going to be 0 over negative 1. And I can have a 0 in the numerator. So that's just equal to 0. So that would be my answer for that one. So undefined for the secant of negative 90, but for the cotangent of negative 90, my actual answer is 0. So undefined and 0. All right. Y'all, I hope this helped. That should answer quite a few of your questions for section 5.4. If you have any questions, please either use the forums, or if that's not helping, send me an email, and have a great rest of your week. All right, thanks everybody.